Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 5, Lesson 12, on transformations of rational functions. So this is supposed to say transformations. Sorry about that. I accidentally said translations. As you can see, I'm on OneNote, and I might make lessons like this from now on because I realized it may be more effective if I actually had text on there, which is what it was like in Jacob Nash geometry lessons back at the beginning of 2020. But then for engineering lessons in late 2020 and then this year, I've used just this iPad. But if I can draw and type, then that would be good because I can be on my computer and type, and then I can be on here and draw, and it'll still work. So hopefully this works good. Let's see. So, I'll just read what it says. Just like any other function, rational functions have transformations too. So do you remember we learned the transformations of quadratics, and we've learned things like that. But you can see that visibly for rational functions too. And the standard or parent function of the rational functions are the reciprocal functions. So when we learned parent functions, I don't remember what unit that was, maybe unit 2. If you remember, one of them was y equals 1 over x, and that's basically what a rational function is, because the standard, what the standard rational function would look like, or parent, where basically it's just normal. So we can see that when there's just a normal linear function, it would look like that, just the y equals x. The only thing about this is that it doesn't have undo, but that's okay, I guess. But, and then remember for quadratics, it was like that. But for this is what it's like for this function. Because the asymptotes on the parent function are just the x and y axis. So how do we get to them to be changed? So we have this standard equation here. So y equals n times 1 divided by x plus or minus a, and then aside from that, plus or minus b. So don't get confused by this. This is just something I created. It's not really like something that your teacher would tell you, but it's to help me explain it. So n, whatever n is, could be a vertical stretch. So we know that sometimes there can be x is up there. We know that from the last lesson. And we know that there can be a different number. So if it was 2, there would be a vertical stretch, which just means that the y values would be more frequent. But that's not necessarily drawable. But also, if n is negative or positive, changes things. If it's positive, then the function will be drawn in quadrants 1 and 3. I already have slightly explained that I said it would be above the x-axis and point to the left like that. So just to review, these are what the quadrants are. The 1, 2, 3, 4. They usually say it's like a C. That's just great. I might have to rewrite this. I think that's dumb that this doesn't have undo, but so I might not use this all the time, but I will today. But if n is negative, then instead it's going to be in these two quadrants. So, oh wait, you might have been thinking, what is he saying? There is undo. I'm sorry, I didn't see that. I've used this on a computer and there was no undo, so that's why I thought that. Okay, so if A is positive, well, not necessarily that A is positive, but if the sign here is positive, then it's gonna be left A units. So if A was 5 and it was plus 5, then it would mean that the vertical asymptote is shifted 5 to the left. We'll look at that more later. And you might think usually negative is what goes left. Well, that's because even though we're looking at A, really it's X. And if A is positive, then X is negative. That's why. And then B is pretty much going to be the value of Y for up and down. That's why it is normal. So when A is negative, it goes to the right, however many units it is. And then B, positive is up and negative is down. That seems normal. And A, whatever A is, well, that's not actually correct. Whatever, it's depending on what A is, kind of if you just set A negative, that's really what it should say. Sorry about that. If negative A, so don't get confused about that. If it happened to be X minus 5, A would not be negative 5. I mean, the vertical asymptote would not be 5. It would negative 5. It would be, if you're supposed to make A negative, then it would be negative 5, which would mean that it's positive. But we already looked at that you can set that equal to 0 anyways, and you would get the same thing anyways. So don't let that confuse you, but that's just to show you how it relates. But don't, just remember from the earlier video that I made of how to find the vertical asymptote. And B is the horizontal asymptote. You might be saying, hey, I thought you looked at the leading degrees to see what it was. And that's true, but if you remember, I said that if the leading coefficient is higher in the denominator, then the horizontal asymptote is y equals 0. Well, that's not the case if there's something right here that's being added or subtracted to the full rational function. And so that is the case because we pretty much, there's no x up here, so it's really x to the 0th, and then that's x to the 1st. So that means that we would think that it's y equals 0 as the horizontal asymptote, but you actually look at what that is, and that's what tells you. But that's only if there is something there. If there wasn't any b, or b was 0, then it would be 0. That's why. So really, I say that it equals 0, but it's whatever b is. And if there's nothing there, then b is 0. That's why we say y equals 0. So if that doesn't make sense, hopefully these examples will. Okay, so describe the transformation for this function. What function? I forgot to draw it, so let me draw one. So let's say we have y equals 1 divided by x plus 2 minus 3. Okay, so describe transformation. So first, basically just remember NAB. That tells you what it is. What's n? There's no n there, obviously, because you're never going to have another variable, but is anything being multiplied by the 1 up here? No. So that really means that it's just 1, so there's no vertical stretch. So you don't need to write anything for that. N is positive, so we can just say that it's a positive function. Now we look at what A is. A is positive and positive 2, so that means left 2. Remember, because positive means left, negative means right for this one. For this one, negative means down and positive means up. So down 3. So that's what we know. That's our transformation, but how do we graph that? Okay. Can I zoom out on this thing? Yes, I can. Thought I could. Okay, so now we can graph it. How do we graph it just with that? Well, I told you in the last video that we can look for holes and x-intercepts and all that, but that's not possible for this one. That's why I'm teaching you this, because knowing transformations will tell you what it is. But we can find our asymptotes. So we can find the vertical asymptote, I said, by looking at this and making it negative, so negative 2, but you also could have just set that equal to 0. So the vertical asymptote is negative 2. X equals negative 2. The horizontal asymptote, I said look at the degrees. There is pretty much x to the 0 up here, x to the 1st. So we would normally say y equals 0, but since there's a negative 3 here, it's y equals negative 3. Oh yeah, I forgot to say that the review video will be next. I said that in the last lesson that it would be this one, but... So that's all we know. So let's go ahead and put these asymptotes on here. So here's one. And then here's one also. Okay, that's not very good dotted lines. Sorry. Okay, so now, since it's positive, we start in the quadrant up here. But it's supposed to remain close to the asymptote, so we actually can make it slightly in this one down here. So that rule doesn't apply to everything. You remember, you have to go through all points, and you have to be near the asymptote but never go through it. So I'm gonna, just so you can see better, I'll make this blue so you can see. Okay, so remember, it's going through, and then it never wants to go through it, so it decides to go up. And then it goes off the graph, so it has to keep going up. Could it keep going up here? No. It only can keep going up here, because we're still going up. Then curve can't go that way, so it goes that way. So that is what it would look like. So that will be it for this video. Hopefully this helped, and I'll see you on the next video, which will be the review. Thanks for watching.